हेलो दोस्तों, मैं हूं प्रकाश और आप देख रहे हैं सिंपली गेम। So, in this tutorial, a natural gas stream containing N2, CO2, and C1 through NC4 is processed in a refrigeration system to remove the heavier hydrocarbons. The lean dry gas produced will meet a pipeline hydrocarbon dew point specification. So let's start the simulation. So first, open the ASPEN HYSYS and go to the component list. Click on the head. So our first component is nitrogen. Nitrogen. Second is CO2. Third is methane. Fourth is ethane. Fifth is propane. Sixth is isobutane. Is N-butane. So this is our component list. Now next is click on fluid package. Click add. So we are going to select Ping Robinson. So Ping Robinson. Now fluid package is selected. Go to the simulation, add a stream. Stream name is feed 1 and the temperature is 60 Fahrenheit and pressure is 600 psi and the molar flow is the molar flow is 6 SEFT. Okay, so now go to the composition. Nitrogen composition is 0.01 and CO2 is 0.01, methane is 0.6, ethane is 0.2, propane is 0.1, iButane is 0.04, and N-butane is 0.04. All composition is specified. Now close it. Now drag the second feed stream, name as feed 2 and the temperature is 60 Fahrenheit, pressure is 600 psi, and molar flow is 4 SCFD. Go to the composition. Composition are based on mass fraction. Click on edit. Click on mass fraction. So nitrogen mass fraction is 0.02, CO2 is 0, methane is 0.4, ethane is 0.2, propane is 0.2, ibutane is 0.1, and n-butane is 0.08. Click OK. So feed stream as specified. Now drag a mixture, double click on it. Inlet first stream is feed 1, inlet second is feed 2, and the outlet is mixer out. close it. Now drag a separator. Choose your model palette. Go on separator and drag a separator here. Double click on it. Change it name to inlet step. Inlet is mixer out. Vapor outlet is separation vapor. Liquid outlet is separation liquid. Okay. That's it. Now close the separator. Now drag a heat exchanger. Drag a heat exchanger. Going heat transfer, and yes, this is a heat exchanger. Double click on it. Change it name to gas, and the tube side inlet is separation vapor. Cell side inlet is LTS vapor. Tube side outlet is cool gas. Cell side outlet is cells gas. Okay. Now click on the parameters. So here we need to enter the pressure drop. So enter a pressure drop of 10 psi for both cell and tube. Okay. So we enter the pressure drop. Now click on the rating tab here in sizing. Now we need to change the tube per cell. Change it to 1. Just click OK. And that's it. Heat exchanger is specified. Close it. Now let's add a chiller. So this is the color. Drag and drop it here. Double click on it. Change the name to chiller. The inlet is cool gas. Outlet is cold gas. And energy is T3 duty. Okay. Now let's go to the parameter. Specify the delta P. The delta P is 10 psi. It's showing the unknown duty. So just left it. We will do it later. Now close it. Now let's add a separator. double click on the cold gas. So here the temperature is not specified. So in this chiller here, the degree of freedom is 2. That's why it's not able to solve this. So here we just specify the temperature to 0 Fahrenheit. So it will automatically solve it. We will change it later. So just left it. Now let's add a LTS, that is low temperature separator. Now again go to the separator, drag a separator here. Here. Drag a separator here. Okay. Now by click on attach. Attach the cold gas to separator. Outlet of separator, that is LTS vapor to this LTS vapor, and then create a liquid stream. Remove the link. Okay. Out of position out. So it will automatically position all the things. Commit, double click on this. So change it name to LTS. So the name is LTS. Now here inlet, outlet, everything is specified. Now close the property view. At this point, the outlet stream from heat exchanger, that is heat exchanger gas are still unknown. So double click on the gas icon to open the exchanger property view. Go on design. So click the design tab and select the specs phase. This is the specs phase. The specs phase allow you to input specification for the heat exchanger and view its calculation status. Okay. So now we are going to adding a heat exchanger specification. So in the specification group, click the add button. Click that button. So in the name cell, change the name to hot side approach. Hot side approach, and the default specification in the type cell is delta temperature, which allow you to specify a temperature difference between two streams. So the stream plus and stream minus cells respond to the warmer and cooler stream respectively. So in the stream plus cell, select stream vapor, select separation vapor, and in the stream minus, select cells gas, and enter the specs value is 10 Fahrenheit. Okay, so the now close this. So this is showing okay. Now click the worksheet tab, then select the condition space to view the calculated stream properties. Okay, using the 10-degree Fahrenheit approach, HYSYS calculate the temperature of cold gas is 42.95 degree Fahrenheit. All stream in the flow sheets are now completely known. Click the performance tab, and in the detail page where HYSYS display the overall performance and detailed performance. Two parameters of interest are the UA and LMTD. LMTD means logarithmic mean temperature difference, which HYSYS is calculated UA is 2.0 is to 2.08 multiplied by 10 to the power 4 BTU per FR, and the LMTD is 22.62 Fahrenheit. Okay, so close this. Now we are going to check the sales gas dew point. So open the model palette. So here just search balance icon. This is the balance icon. Drag and drop it here. Okay. Double click on the balance icon. So it will show like this. So in the name field, type dew point. Okay. So the inlet, click in the stream shell in the outer stream table and enter the outer stream table stream by typing sales dp. Yes. Okay. And the inlet stream is sales gas. Sales gas. Okay. Now click on the parameters tab, and here we are going to select the component mole flow. Okay. Component mole flow is selected. Now click the worksheet tab. The vapor fraction and pressure of sales dp can now be specified, and HYSYS will perform a place calculation to determine the unknown temperature. So in the sales dp column, vapor cell, enter 1, and in the pressure cell, enter 800 psi. So HYSYS places the stream at this condition, returning a dew point temperature is 5.273 degree Fahrenheit, which is well within the pipeline of 15 degree Fahrenheit. Now close it. Again we are going to add a mixture. So open model palette, drag a mixture here, double click on it. So the first inlet is LTS. Oh, wait. Change this name, LTS. Now double click on mixture. The first inlet is LTS liquid, and the second inlet is separation liquid. The outlet is tower speed. Tower speed. Okay. Close it. You can just probe the self dp near the dew point. Okay. The mixture is specified. Now we are going to add a distillation column. One separator is a distillation column. Drag and drop it here. Close the model palette. Double click on it. Okay. So now we are going to enter the condenser energy stream name is condenser duty. This is full reflex. Overhead vapor outlet is overhead, and the boiler duty is the boiler duty. Bottom liquid out is this is liquid product. Okay, liquid product. The inlet stream to the tower is tower feed. Here we are just keeping the number of stages as 10 and the inlet feed entered stage 5 of the main tower. Now click on the next, again next. So here we are going to specify the condenser pressure is 200 psi and the boiler pressure is 205 psi. 105 psi. Okay. So again click the next button. So these values are optional, but we have these values. So I am going to enter these values. Condenser temperature is 40°F. The boiler temperature is 200°F. Okay. Click on next. Reflex ratio. First vapor rate heat is 2 mm SCFD and reflex ratio is 1. Its flow basis is molar only. Click done. So distillation column property view appear. Now select the monitor page. The monitor page displays the status of your column as it is being calculated, updating information with each iteration. You can also change specification values and activate or deactivate specification used by the column solver directly from this page. So the current degree of freedom is 0, indicating the column is ready to run. The vapor rate we specified in the input expert, however, is currently an active specification, and you want to use this only as the initial estimate for the solver for this exercise. So in the vent rate low, click the active checkbox to clear it. Okay, leaving the estimate checkbox selected. The degree of freedom will increase to 1, indicating that another active specification is required. For this example, a 2% pro propane mole fraction in the bottom liquid will be specified. Select the specs page. This page lists all the active and non-active specification which are required to solve the column. In the column specification group, click the add button and the add specs property view appear. From the column specification type list, select column component section and click on add specs. So in the name cell, change the specification name to propane flux fraction. Propane fraction, and in the stage cell, select reboiler. In the specs value cell, enter 0.2, 0.02 is the liquid mole fraction specification values. Now click on the first cell component in the component list table and select propane. Select propane. Now close it. Again go to the monitor And here we can see the propane fraction. This is automatically active and the degree of freedom is 0. Okay, so now click the run button. The information displayed on the monitor page is updated with each iteration. The column converts quickly in 3 iteration. The table in the optional checks group displays the iteration number, step size, and equilibrium error and heat and specs error. The column temperature profile appear in the profile group. You can view the pressure and or flow profile by selecting the appropriate radio button. The status indicator have changed from unconverged to converged. Now click the performance tab and select the column profile page to access a more detailed stage summary. Okay, so now we are going going to install an adjust for calculating the LDS temperature. Suppose the market price of your liquid product is currently unfavorable and you want to raise the LTS temperature to leave more of the heavier component in the gas phase. This will increase the sales gas heating value, resulting in a bonus from the transmission company. The sales gas must, however, still comply with the dew point specification. An adjust operation can be used to adjust the temperature of LTS, that is cold gas stream, until the sales gas dew point is within a few degree of the pipeline specification. In effect, this increases the gas heating value while still satisfying the dew point criteria. The adjust operation perform automatic trial and error calculation until a target value is reached. So open the model palette and search for adjust. So here is the adjust. Just drag and drop it here. Close the model palette. Now click the attach mode icon on the PFD toolbar to enter attached mode. The attach mode. Now position the cursor over the left end of adjust one icon. The connection point and pop-up adjust object error. With the pop-up visible, left click and drag toward the cold gas stream icon. Cold gas. Okay. When the solid white box appear on the cold gas stream, release the mouse button. The select adjusted variable property view appear. At this point, HYSYS knows that the cold gas should be adjusted in some way to meet the required target. An adjustable variable for the cold gas must now be selected from the select adjusted variable property view. From the variable list, select temperature, click the done button. Now position the cursor over the right corner of adjust one icon and connect it to the cell TP. From the variable list, select temperature and click done. Okay. Now close the attach mode. Double click on adjust one. So the next task is to provide a value for the target variable. In this case, the dew point temperature, okay, a 5 degree Fahrenheit safety margin will be used on the pipeline specification of 15 degree Fahrenheit. So the desired dew point is 10 degree Fahrenheit. So in the connection phase, enter 10 degree Fahrenheit in the specified target values. Now click the parameters tab. In parameter tab, enter 0.1 degree in the tolerance cell. 0.1 degree Fahrenheit. In the step size, enter 5 degree Fahrenheit. No value will be entered in maximum and minimum field. So now click on the monitor tab. This tab enable you to view the calculation. Click the start button. So the adjust converts on the target value within the specified tolerance in 4 iteration. An LTS temperature of 4.441 degree Fahrenheit gives a sales gas dew point target value of 9.99999 degree Fahrenheit. So the adjust has changed the LTS temperature from original value of 0 degree Fahrenheit to 4.4 degree Fahrenheit. Now you can see this in the cold gas. So here first we specify the cold gas temperature is 0 degree Fahrenheit. Now the adjust automatically changes to 4.441 degree Fahrenheit to match the specified temperature. Okay, this was a just an basic example of ASPEN HYSYS. Here you can see the in liquid product. Go to the composition. So here you can see only I-butane and N-butane are available in the liquid product because this is these are the heavy component, and our target was to separate the heavy component from the light component. In the overall product, in the composition, you can see some part of nitrogen, CO2, but most of methane, ethane, and propane. This is the just a basic example of एस्पेनाइसिस. अगर ये वीडियो आपको अच्छा लगा हो तो लाइक करें, शेयर करें एंड चैनल को सब्सक्राइब जरूर करें. मिलते हैं नेक्स्ट वीडियो में. टिल देन कीप लर्निंग, कीप सिमुलेटिंग.